Welcome back to Aurora Tech Channel. Today, I will review the Comgrow T300. Last year, I reviewed the Comgrow T500, which was a large 500mm cube printer. It's the largest bed slinger I've ever tested. This T300 is a new machine from the same series and the first printer from after Comgrow has merged with Sovol. So, let's see what we can get from this new T300. The print volume of the machine is 300 by 300 by 350 millimeters. As the size of this machine is larger, the space required would be around 21 inches in width, 30 inches in depth, and 35 inches in height, including all the space for the heated bed and spool holder. The machine weighs close to 40 pounds. It's a bed slinger with a modular linear rail motion system on the X, Y, and dual Z axis. The X axis is belt driven with a single linear rail, the dual Z axis is also a single linear rail with lead screws, and the Y linear rail is similar to the X axis, but with an extra linear rail added to improve stability. The claimed maximum print speed is 600 millimeters per second with a 12K acceleration. The maximum flow rate of the hot end is 30 millimeters cubed per second. When converted to a 0.2 millimeter layer height and a 0.4 millimeter diameter nozzle, it would be around 375 millimeters per second. Inside the print head, we have a 6.5:1 ratio metal gear extruder, and the part cooling fan is a 5025 8500 RPM turbo blower installed at the back of the print head. There's an inductive sensor for auto bed leveling. The nozzle is a Bamboo Lab style nickel-plated copper nozzle with the maximum temperature of 300 degrees Celsius. The heated bed is AC powered, and it can reach up to 100 degrees Celsius with a textured PEI print surface. The machine uses an MKS Pi motherboard with silent stepper drivers that support sensorless homing. It runs standard Clipper firmware with a Moonraker API and Mainsail web interface, so you can print directly over the network with any major slicer. The touchscreen UI is their own UI, and the size of the screen is 4.3 inches. For other features, it has a dual USB and RJ45 port, filament sensors, and LED light on the print head, and belt tensions are adjusted using the screws on the modular linear rails. I would like to thank Comgrow for sending us this machine to review, and I'd also like to thank FlexiSpot for sponsoring today's video. We have been using FlexiSpot standing desks for over a year. Our first FlexiSpot desk was actually bought with our own money before they sponsored this channel. Recently, they've launched the new C7 office chair, which received the CNET Best Office Chairs of 2023 award. We use it to replace our gaming chair, as this old chair was tilted to one side and the piston for raising the chair was also no longer working well. We've already been using the new C7 chair for a few weeks. Some unique features include its self-adaptive design, which has a lumbar-supported cushion that can be adjusted automatically according to your posture. Every part of this chair is adjustable, and it supports weight up to 300 pounds. It can lean forward and backward with a large 20-inch seat, allowing us to sit cross-legged and even take a nap on it while we're recording video clips. If you're interested in the FlexiSpot C7 chair, visit FlexiSpot.com and use the code C730 to enjoy a $30 discount. The machine comes with a large box, especially compared to an Ender 3 box. All parts are well protected with laser-cut foam, and the structure of this machine is simple. We have the Y-axis linear module installed on the base, two Z-axis modules, the X-axis module with the print head, a filament holder, two brackets to reinforce the Z-axis, a 4.3-inch touchscreen, some sample filament, and some tools and cables. I will start by putting the Z-axis modules on the base. The good thing is you can tighten the screws from the top without flipping this heavy printer over and tightening those screws from the bottom. Then, install the bracket to reinforce the Z-axis and do the same to both sides. Next, put on the X-axis and secure it by tightening the screws at the back. We can now connect some cables and put the cable chain on top of the X-axis and do some cable management with the small clips that secure the ribbon cable. Then, snap the screen at the front, install the spool holder, and we're done. As the screen UI of this printer doesn't come with the setup wizard, we need to go to the menu and set gantry level, the Z offset, and auto bed leveling. To set up the Wi-Fi, we also need to configure the SSID and password by using the settings menu. I will start our first test print with Sunlu Yellow PLA to print a sample Benchy. The sample Benchy is a fast one, so the first layer is being printed very aggressively. I will let it print a few more layers, reach its top speed, and then test the sound level. The sound meter is placed 6 inches away, and the sound level stays at around 60 decibels. The print finishes in 14 minutes, so even though it's a 0.25mm layer height Benchy, it's surprisingly fast. The surface quality is not the best, but it's still not bad considering the size of this bed slinger, printing at such a high speed. As this printer supports Orca Slicer and comes with a printer profile, I will use Orca Slicer to slice a normal 0.2mm layer height Benchy using the default PLA profile. The print finishes in 36 minutes. The layer height and the surface quality look slightly better, but I think the 14-minute one is still pretty decent. The 36-minute one sliced using the default PLA profile didn't make a huge difference. However, we can see some minor cooling issues on the 14-minute one, while the 36-minute one did a much better job. Let's start with some of my usual test prints, starting with a Honeycomb box to test the retraction of the extruder. As this model requires printing a tiny bit of filament and retracting immediately, it could be a tough test for an extruder. I noticed that the default PLA profile has a nozzle temperature of just 200 degrees Celsius, which is lower than the normal range of 220 degrees Celsius when printing PLA at high speeds. However, since this printer uses a nickel-plated copper nozzle, this type of nozzle generally prints better at lower temperatures, as copper usually offers better conductivity and temperature stability than brass. So let's see how it performs. The print finishes in 2 hours and 40 minutes. All honeycombs were printed successfully without any broken patterns. However, the stringing is more than expected. Let's compare those printed by other machines with the same Sunlu PLA. All of them can print all the patterns without broken honeycombs, but this T300 and the Cheedy X-Smart 3 have more stringing. Then, I will print the number slider for the clearance test. As the tiles have to move freely, we need to see gaps in the first layer. If the Z offset is too low, all tiles will stick together and won't work well for this model. The Z offset I set previously seems fine. The print finishes in 2 hours and 12 minutes. The top surface looks alright, with no stringing at all. The bottom is also printed nicely, and you can see gaps between tiles. All tiles can move freely without issues. Up next, I will do a tolerance test by printing my own simple geometry model. The print finishes in 2 hours and 2 minutes, which is a little faster than the 2.5 to 3 hour average time for other new generation clipper machines. For the square, it can clear all the way from 0.225 to 0.05mm, which is the perfect score, so it seems the pressure advance is well calibrated in the factory. For the cylinder, it can also clear all the way from 0.225 and get stuck at the final 0.05 millimeters, which is almost perfect and is really unexpected. The surface quality is not the best, but the tolerance is one of the best I've ever tested. Then, I will do a decorative print, the Robo Alpaka. The print finishes in 3 hours and 53 minutes, which is also faster than most other new clipper machines, which require around 4.5 hours. The surface quality is actually pretty good, and the stringing on this model is minimal as the nozzle doesn't require that much mid-air travel. Let's take a look from all 4 angles and do some comparisons. Compared to the Comgrow T500, which is a huge bed slinger with a print volume of a 500 cube, the surface quality of this T300 is much better. The print time is also 2 hours faster, as both the maximum print speed and acceleration of the T300 are faster. Compared to the Ender 3 V3, the surface quality of the Ender 3 V3 is slightly better, but the print speed of the T300 wins. Compared to another large bed slinger, the Neptune 4 Max, the surface quality is similar, but the T300 is an hour faster. Finally, when compared to the K1C, the K1C Core XY's more stable box frame does deliver a better surface quality than the bed slinger, but the T300 still printed faster. Let's try some different materials, starting with PETG. I will print a larger 320mm tall trash can. It seems the first layer is printing very well, and when printing the lower part of the trash can, the ringing is minimal. However, when the print gets taller, printing at a high speed on a bed slinger shows quite a lot of ringing. The print took 7 hours and 22 minutes to finish. Once again, the bottom half of the trash can is alright, but the top part may need you to slow down or use a larger diameter nozzle. While it can print at a slower speed with better quality, a thicker layer height like 0.6 or 0.8 millimeters can decrease the total print time. I will talk more about this later. Up next, I will print an ABS mesh bottom crate. The first layer looks good, and it sticks perfectly to the glue. This crate finished in 3 hours and 36 minutes. It stuck to the bed pretty well with glue, but the brim is actually not helping much as it's distanced from the model. When printing ABS without a stable ambient temperature, the plastic shrunk and caused some imperfections here. The layers aren't cracking yet, but it is unavoidable to show some imperfect layers and warping while printing ABS on an open frame printer. But overall, this ABS print is just okay. The part is still usable with some manual cleanup. Then, I will print a simple TPU wallet. This print took 54 minutes to finish. When the TPU is dry, the surface quality is really good. This is a perfect print, and the side and bottom all look good. I have no complaints about this print. As this printer came with a nickel-plated nozzle, it does work with carbon-filled filaments, so I would try to print nylon carbon fiber with it. As I dried this roll of PACF last week, I would try to just print it without extra drying and see how it does. It's actually not bad, but it looks like the roll has already moistened after a few days. I dried the filament for 14 hours before restarting the print. This time, the cable holder was printed perfectly. We can see some differences between these two prints that ran the same G-code. As long as the nylon filament is completely dry, it's actually pretty easy to print. Finally, I will do a first layer test. At first, the auto Z offset is set a bit low, so I will reset the Z offset and restart the print. It's a pretty good first layer considering the size of the bed, apart from these corners being still a bit too low, but it should be good enough for most prints, even for larger ones. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. The X, Y, and Z axes are all using modular linear rails. This could be the best motion system on a bed slinger, as it moves smoothly and would be a much better option than using palm wheels, especially on a fast clipper bed slinger. 2. The part cooling fan is using one 5025 turbo blower. Even though it doesn't come with a large auxiliary fan like many other printers, the cooling seems to be working pretty well. I can't see cooling issues with most prints, except for the super aggressive 13-minute Benchy. 3. It uses native Clipper firmware with the Moonraker API installed. This means you can use any slicer and send the print job over Wi-Fi without going through a third-party cloud server or being forced to use a slicer you don't like. The latest Orca slicer already has the Comgrow T300 profile. Just enter the IP address for your printer to print over your local Wi-Fi. This is definitely the network printing workflow that I prefer. 4. This machine didn't come with an accelerometer, and the input shaping is pre-calibrated, but surprisingly, it works better than some machines that do come with an accelerometer, thanks to its sturdy build and 40-pound weight. 5. The pushing force of the 6.5 to 1 gear ratio metal gear extruder is strong. I experienced zero nozzle clogging during the entire testing process, which included switching between different filaments such as PLA, PETG, TPU, ABS, nylon carbon fiber, and then back to PLA. Now for the cons. 1. This printer's screen UI is fully functional, with a menu system that includes most features you would need for a 3D printer. However, I found that these translations of the menu are a bit awkward. While you can still understand what it's saying, it lacks the common terms you would expect for 3D printing. Also, when trying to reprint a G-code file started on the 8 GB of eMMC, the files are sorted alphabetically, which become inconvenient if you have many files, as you need to scroll through multiple pages to find it. It would be more logical to sort the files by upload time or the last printed time, or provide the option for the user to choose their preferred sorting method. Personally, I don't see the benefits of using a self-developed screen UI rather than just using the standard Clipper screen UI, especially on a machine with no real unique features that require customization. Honestly, I like the standard Clipper screen UI of the T500 or the Soval SV07 much better. 2. Despite being a new machine in 2024, this printer does not have an auto-Z offset function. Instead, users still need to manually adjust the nozzle height using a leveling card or paper. While I'm personally okay with that, particularly for prints like number sliders and one-layer PLA sheets that require more accurate Z offsets, but the absence of auto-Z offset could be seen as a drawback for some buyers, especially when compared to competitors that do offer this feature. 3. While there is no top bar on the gantry, the modular linear rails are rigid enough that I don't believe adding one would make a huge difference. However, I do still see benefits in having a top bar, not only for aesthetic reasons, but also for practicality. For example, the spool holder could be mounted in the middle of the top gantry, which I think could be better than mounting it on one of the Z axes. 4. The Orca Slicer profile only includes one PLA preset. If you need to print PETG, ABS, TPU, or any filament other than PLA, you'll need to create your own profile. While more experienced users can do this, it would be helpful to include more commonly used filament profiles, allowing beginners to print a broader range of materials right out of the box. Additionally, due to the unique properties of the nickel-plated copper nozzle, which requires slightly lower temperatures, tuning the profile for different materials may involve lots of trial and error. Moreover, there aren't larger diameter nozzles on their website yet. I asked Comgrow, and they said different size nozzles for the T300 will be available soon. But I think it would have been better to have the nozzles ready when your printer is being launched, especially since you can't get good results using a 0.4mm nozzle when printing tall prints at high speeds on such a large bed slinger. In conclusion, the modular linear rails on this Comgrow T300 makes it the best motion system among all bed slingers in the market. It's a very capable printer that handles a broad range of materials well, with an above-average print speed and print quality. Regarding firmware, the standard Clipper firmware allows for seamless printing with any slicer over the network. While there are minor issues with the screen UI and slicer profiles, these can likely be fixed through simple software and screen firmware updates without hugely impacting the printer's usability. However, the absence of auto-Z offset and CAN bus single cable management can be considered drawbacks for some users. Overall, though, the Comgrow T300 with its build and performance, surpassing other mid to large size Clipper bed slingers that I've tested so far. If you're interested in the Comgrow T300, I put the link to it under the description. I also added the link to my website, auroratechchannel.com, which tracks the prices of over 150 popular 3D printers. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.